Okay, we'll continue today from where we stopped yesterday. Okay, so yesterday we are seeing collections and Java support for it. Yeah, I had given you some key points yesterday. Now one more point you can add to yesterday's key point. We had written down this much. Okay, so the third point which you are adding now is all collections are eligible for cloning and serialization, because all collection classes are implementing to mark interfaces which are interface clonable and interface serializable. Okay, just write it down. What's library to study? We'll see. Even those two interfaces you have to study. Okay, so we are continuing from where we stopped yesterday. So now what we'll do is, yesterday you saw the hierarchy of all the classes and interfaces. We went with collection interface yesterday. Today we'll start seeing other interfaces. Okay. Today we'll start seeing other interfaces. See, the collection framework, yesterday we saw that hierarchy. It's classified into three main categories. One is list, the other one is set, and the other one is map. Okay, so list allows what? A collection of objects with duplicates. Okay, set, collection of objects without duplicates. Map is used for storing key value pair. Understood? So this is the three major classification you've got here. So we are going to pick the first one, which is list. Okay, and list is an interface which extends collection interface. You saw that yesterday. Okay, and list allows what? Duplicates. Any class which implements list allows duplicates. Okay, and all classes implementing list interfaces store values using index notation. Okay, and list has many concrete implementations, but some of them we are going to study, not all, because we don't use most of them. Okay, see, vector, array list and linked list, which are very frequently asked in interview. So we are going to cover which one? Among this we are going to see array list today, because that's the most important one. Okay, throughout your life you'll be using maximum of array list, or one more is there called as hash set. These are the two extensively used these things. So we'll go back to this hierarchy now. Let's see where they stand now. So today we are going to cover, see, I said there are three main categories. What are the three main categories? List, set and map. See, here you got, okay, collection is that interface. Okay, and in that you got set and list. Queue is there, but leave it. But any class you can see here, they are either implementing what? Set and list. Any class you can see, they are either implementing either set or list, very neatly organized. See, a collection is very simple. It will either allow you duplicates or it will not allow duplicates. First, that's the major classification. So that's what they have done. And yesterday this was not there. Okay, I have added it today. Which one? Stack. This is a new thing what we have added. Just add it down. And if you have written down the diagram, you can add this one thing extra. Which one? Stack. Okay. So this is the hierarchy now. So one, see, we have got three main categories. One is list, set. Okay, and the other one is map. I'll show you that. So in the list implementations, there is array list, vector and linked list, also stack. So now see, coming to this map, I got map also. So three main categories. These maps are used for storing what? Key value pairs. We'll see this later. First we'll complete collection, then we'll go with key value pairs. So here the most important, as I told you, is array list, and one more which is used extensively is hash set. These are the extensively used ones. So I'll be more focusing on array list and hash set only. Okay. Others, okay, see, I'm not telling they are bad structures. Okay. They are good structures, but we very rarely use them. Why? Because of performance. Okay. In our scenarios, when you are developing applications now, we don't need those structures. Especially we application developers, do not need those kind of data structures. We application developers maximum need what? Array structure and hashing technique. These are the only two structures what we use extensively. Other structures we don't use. Like example, stack, queue. It is there. Java is giving support to that in the library, but we don't use it. So Java gives you the library support, but end of the day you have to decide which one is flexible to you. Means for your usage. You have got a scenario now. In that scenario, which one is good? That you have to decide. So that's why we'll be spending maximum time on this one, array list and this one. These are also there. Queue is there, stack is there, linked list is there, tree technique is there, many are there, tree structure is there, many are there. Okay, so this is the framework. So this is the one. So you can take the heading today as array list. So we'll be starting off with ArrayList. This is the main class. You can study it in any order, but I am picking the most important one first. Reason is we should not get tired learning unwanted things here. What is really important, we'll finish it off first. Unwanted things, how much are required, we'll learn that much. Okay, you can study it in any order now. So now coming to ArrayList. ArrayList is going to support what structure now? See, one class represents one structure here, encapsulating one structure. ArrayList represents array structure. Vector also represents array structure. Stack, linked list, stack represents stack structure. Linked list represents linked list structure. Priority queue represents queue structure. Tree set represents tree structure. This one hashing technique, this one also hashing technique. So one class is giving you support for one data structure here. Okay, that's how they are organized. And the beauty of this framework is what? Almost all you got a standard approach to work with most of the structures. Okay, standard approach, because the common methods will be kept in the interface. Extra methods they go on adding wherever they want. Okay, that's what is inheritance about. So that is also fine now. Now coming to array structure, ArrayList now. See, ArrayList was designed to support array structure. Understood? So we'll start off with ArrayList. So ArrayList was mainly given for you to support what? Array structure. Some points you can note down about ArrayList. Then we'll start off. See, ArrayList, some points, just write it down. After completion you'll start understanding all these points. ArrayList is a class used to store multiple objects. It uses array data structure internally to store the elements. Yesterday we studied this, so we are going more deeper today. ArrayList stores values sequentially. It will store one after the other, but they can be accessed randomly. Means you can get it from any index. We are going to see that point. See, it will store sequentially one after the other, but when you want, you can get it from any index. 5th element, 10th element, 11th element, like that you can get it. ArrayList can grow and shrink dynamically. Duplicate values are allowed. It is not synchronized. Okay, values will be stored in the same order as inserted. Yesterday's points, almost all. Okay, the elements in the ArrayList can be accessed by iterator and list iterator. We'll go to that point, don't worry. ArrayList elements can be accessed randomly because it's implementing random access mark interface. Just write down the points. Then what are the advantages of ArrayList and disadvantages? Both you should know. So it provides very fast iteration. Iteration means visiting elements. Sometimes you want to visit the elements. Okay, so that time it gives you very fast access. So if you want to really visit all the elements, that's called as traversing. Technically it is called as traversing. Okay, if you want to visit all the elements, okay, ArrayList has got better performance over linked list. So if your real requirement is traversing and visiting all the elements, better you go for what? Array structure. What are the drawbacks of ArrayList? Insertion deletion operation is a bit slow. I'll explain you this topic. So if you want to do too much of insert and deletion operation, better you go for linked list. So depending on the scenario and situation, you will choose your data structures. But in Java, the idea is you don't have to invent your data structure. You just have to use the data structure. Just understand the behavior of them and just start using it, because all these classes are nothing but data engines. Yes or no? They are classes which are nothing but data engines, and they are implementing those corresponding data structure. So the one which we are going to study now is ArrayList. Yes, to start off with ArrayList, yes, see this. ArrayList is representing which structure? Array structure. You know that very well. So see, whenever we have got languages. I'm not saying no. We have got languages. Plenty of languages are there. All languages give you extensive support for storing data in primary memory. They give you data types. In data types they give, there are 3 types of data types. What is that? You know, every language will give you these data types. Okay, you take C, C++, Java, any language you know, you take data types. It is classified into 3 categories. Primitive types means they gives you primitive data types, int, float and all that. Then comes derived types, means array. Example for derived type is array. See, all languages give you the support for array. Then you got user defined type. In one language you got one. In C they call it a struct. enum, something they call, okay, in C++ they call it as class, subclass. In Java we say class, subclass, abstract class, interface, but all languages give all the three support. But which is giving you more powerful support is the question. Okay, so that you leave now. But all languages give you the support for which structure now? Array. C also gives it. So array is just a general concept. These language people, what they are doing? They are facilitating it by providing it to you built-in. See, supposing I want to store a group of values in C language. Now if array was not there, what would have you done? You have to invent it now. Because that structure is a good structure. You want to store multiple values. So that is a common, at least all languages are giving basic support for what? One structure. Basic support. Okay, C also gives you the basic support for array. C++ also gives the basic support for array. But they don't end up in giving more support for other structures. One basic they'll give you. Understood? But see, array is a general concept. And these data structures are very huge subject. Okay, years and years and years of revolution has happened of handling data in primary memory. Okay, that one point you have to understand. Okay, so many, around 50, 60, 70 years have passed only to do what? Research on storing values in primary memory, and then these data structures are come into existence. Okay, it was not invented yesterday night and today morning we are studying what? Tree structure, array structure and all that. Lot of revolution has happened. It takes lot of time for you also to understand this particular structures. It's not like 5 minutes you understood the data structure, oh you know everything, you can't. Okay, so through experience and with proper learning you will go on understanding all these powerful structures. So one of the structure which is extensively supported by all languages built-in is array. Among them, one of the structure, among the multiple structures, one of the structure which is supported is array structure. Understood? So then when they are giving it, C gave you, C++ give you, Java also has to give you, otherwise what will happen? We will not use it, no. So when you are choosing a language to learn, you choose the best language. So language which has many features we choose. So Java also is giving it. So yes, array support was there in Java. I'm not saying no. And how do you work with an array in Java? Built-in it is. Arrays are treated like objects. If I want to store some integer values, I'll create an array. Int a is equal to new int of some index you'll give 5. This is an array of what? Integer. If I want an array of strings, string s is equal to new string of 5. Sorry, you have to use the square bracket. If you want an array of user defined type, that also you have seen, box we did. Understood? So or if you want, you can go for employee. E is equal to new employee of 5. Means for this you have to write your user defined type now. It's an array of what? User defined type. So these are built in. Primitive is built in, string is built in. But for this you can write your class employee. And then you can define int id, string name. Because when there are many employees, you can go with what? An array of. You got an excellent support. I'm not telling no. Okay. So, but there are some problems with array, which you will understand. Okay, which after covering all this you will understand. There are some problems. Like some of the problems with this. See, array structure is not bad. Just understand the point here. Array structure is not bad. The implementation is bad. Understood? Array is a very good structure, but the way they have implemented here, there are some problems. Like what? Size is fixed. Okay, it cannot grow and shrink dynamically. Okay, and you cannot add an element at a particular index. Like supposing I got an array of what? See this. This is an array of what? 5. So when I create this integer array, you'll have how many indexes? 0, 1, 2, 3, 4. Look at the problems. It is fixed. I'll insert some values 100, 101, 102, 103. You know how to fill the values now? I've covered arrays long back. So I'll tell like this, a of 0 is equal to 100, a of 1 is equal to 101, like this you'll fill, stored. Now I want one more value to be inserted at the second index. What will you do? How will you do? It is not possible. It will overwrite. Understood? So like this you have stored the values. A of 0 is equal to 100, a of 1 is equal to 101, a of 2 is equal to 102, a of 3 is equal to 103, a of 4 is equal to 104. Yes, values have been stored, agreed. But in the second index I want one more value now. First of all, it is fixed. On top of that, if you try to add, what will happen? It will not grow. But I try to do it. See here, a of 2 is equal to 2, 2, 2. One more value. In the second index, this overwrites. I am not interested in overwriting. I want one more value to be added to the specified index now. So array is a good structure. What does the array structure tell? Does the array structure tell size is fixed? Array structure is not telling size is fixed. Okay. Array structure tells, what does the array structure tell? It is going to store the values sequentially and you can access it randomly. I want from the second index, you want from the fifth index, it will give it to you. Okay. So that's what is array structure telling. But they did not implement it in, these are the extra things what the developer requires today. Okay, they gave the language people gave the support, but we need more support. So to to support all this, see, one is you can write the logic. Okay, but Java says no, you don't write. We will only give it in the library to you, and that is when in the first version of Java, if you go to the history, Java 1.0, what was released to support all these problems? Size is fixed. You can't insert a value in between, and supposing I want to remove an element, is there any way to remove an element? Remove an element, let me see. You can't remove it. I want to remove 103. How will you remove? There is no mechanism. So like this, some problems are there. More problems are there. Just I am telling you the problems which you can understand right now for the time being. So it is fixed. You can't remove. You cannot insert a value at a specified index. To overcome all these problems, one class was released in Java 1.0 called as vector. So vector is a class which encapsulates what? Array structure. And it will give you solution to all the problems what we discussed. Okay, whatever we discussed, it will give you. But the problem with vector is, it is a synchronized class. It is a synchronized class. Synchronized means what? Only one means if in a multi-threaded environment, if that object is used by multiple threads, definitely it will bring down the performance, because one thread is using that object, another thread cannot use that object. So it will bring down the performance drastically. So new support was required. So in 1.0 it was released. Okay, so they gave the support. Initially they thought it should be synchronized. See, when they are inventing libraries now, they can't just in one shot decide and design something. They'll come with some problem, they'll give a solution. More problems are there, they'll go on inventing again. See, necessity is the mother of invention. That is what engineering subject says. So that is when a new class was introduced called as ArrayList. They didn't modify it. They let it remain as it is. They didn't modify, because if they modify, what will happen now? You know the rule. OOP strictly says once a class is designed, never modify it. Okay, they should not modify it, because you might have used it in old projects. Now they change something, it will have effect. So they let it remain as it is. Then they added a new class called as what? ArrayList. So this is a history. Okay, so we are learning collections from 1 point means up to 1.4. 1.4 5 story is different. Yesterday I told you. Right now we'll be covering up to what happened till 1.4 version of Java. Okay, 1.5 story is next. So that is syntax change. Lot of syntax change is there. So that we'll be learning later. Again to support collections only. So first, if you understand all these concepts of data structure and all that, there only you'll have to learn what? Syntax. Concepts all will be same. Okay, they'll only give you better support, that's it, for programming. Okay, so they added ArrayList. So this is how the history went on. So definitely, see, in projects many times you will not use array also. Primitive arrays will not be used. Vector also will not be used. It is legacy. Understood? We call it as legacy class. Extensively used class is ArrayList. So I could have gone on teaching you vector and then come to ArrayList in the same way how they came. But we'll be wasting time in learning vector. The same effort if you put in learning ArrayList, it will be helpful for you. So maximum time we'll spend in learning ArrayList structure. But ArrayList is encapsulating what? Array data structure. Okay. Now when they were adding, see, not only this, in 1.0 this was added. In 1.2 this was added. In 1.0 when they released, there were most problems. What were the problems? If you see the history, what is the history telling? Initially only less support was given. Yes or no? What was the support given in 1.0? Only some 4-5 classes they gave. Which one is that? Vector stack, hash table, properties. Okay. So like this they gave some 4-5 classes, but developers needed more structure, data structures. So they thought of adding it. But now for one class they didn't want what? One name and one method name, because functionality end of the day will be same. What you will do? CRUD operations. Same, almost means inserting a record, updating. CRUD means creating, reading, updating, deleting. Means inserting, reading, updating, deleting only you will be doing. So the same operations were there. So that's when they thought, instead of inventing new classes and all that, let's create on framework. That hierarchy they created. Which hierarchy? Getting the idea now? How they started inventing the framework. This is history. So this hierarchy was created. Okay, first this hierarchy was created, then they went on having concrete classes, implementing them. So interfaces state always what they do, but not how it is done. Point number 1. Second point, okay, interfaces set standards. Okay, and it also interfaces help you to decouple declaration and implementation. Sometimes you don't want to do implementations, so they bought it. And the advantage of this is, tomorrow also if they want to implement a new structure, it will fall in one of this category. So you are not burdened with learning what? More method names. This is their idea. You should not go on learning what? For the same functionality. Why do you want to learn more method names? In one class for adding an element it might be M1. In another class for adding an element it might be fun. In another class means for another structure for adding an element the method might be test, show. So how many methods? It's not possible. So that's the reason they came with this particular framework now. Clear? So this is history. So let's straight away start with ArrayList, data structure now, and go more deeper into all the things now. Clear? So this was about the history of ArrayList. Still more changes have happened in ArrayList, this one in 1.5. We'll be seeing it. And we'll go with the first example what I covered yesterday. Is this first example clear for you? So yesterday I wanted to store the values in which structure? Array structure. I didn't use primitive array. I didn't use vector. I went with ArrayList. Reason is it is used extensively. Understood? So see here, initial size. You know some of these methods now. List.size. List.size now is the method. Initial just change the name to AL so that it becomes visible. ArrayList is what? List.size is empty. Are you clear this? So first I created an ArrayList, so an object gets created. Understood? So in this object you added some elements. After adding list.size is what? So it will be the respective size. And Vishan, next is empty will be false. And if you want you can check the methods. What? Contains. Does it contain the element? Okay, here it was giving you what? True. Here it was giving you false because there is no element called as R. Then if I want you can do remove operations. Okay, I removed an element. Then I check the size and list. And if you want you can remove all the elements by calling clear method. So I think this example is pretty clear for you, which we saw it in the yesterday's class. So today we'll go with the next example of ArrayList. I've added all the examples here itself. Let's see how to do CRUD operations with in ArrayList. I didn't show you how to do full CRUD operation. CRUD operation means C means creating, R means reading, U means updating, D means deleting. So we are learning how to do these 4 operations in primary memory in array data structure. Do not forget that point. We are learning how to do inserting, updating, deleting and reading operation in primary memory using array structure, array data structure. Clear? So this is how it goes now. Yes, let's start off now. See, ArrayList, you know how to code. So you start coding now. You will create an ArrayList. Once you create the ArrayList, next what? Size is what? 0 is empty is true. A list is what? It will not print any values for you because there are no values inside it right now. Next, see here. This is the feature of ArrayList. Okay, it can add duplicates. It can add null values and at the same time it can add dissimilar elements also. Yesterday what you saw, you can see the first program, you are adding all what? Similar type of elements. So more concepts to learn now. All were of type what? String. Anything is in double quote what? string. Okay, so but you can see here we are able to add what? Dissimilar data. What are the dissimilar data I am adding? See, all I am adding. First I created, up till here fine. Okay, same one is, this is an example for duplicate. A is already there, I can add a duplicate. Then next, you can add null, no? Yes, I can add null. These two we saw yesterday itself. But one more, you can add what? Dissimilar element also. I am adding what here? Integer. And you know the key point of collection? You can't add primitives into collection. So that's why I am doing boxing and then adding. Understood? So new integer of 10 and then I add it. Clear? Clear this? So fine now. So these are the main, this is the main thing about ArrayList now. Okay. So it can hold duplicates, null and dissimilar elements. Okay. Because one structure will have one behavior. Tree set will not allow duplicates. We discussed yesterday. But here this structure allows you these three things. Fine. After adding, see, means to add now, means this is nothing but what? Inserting a record now. To insert, it is nothing but what? We are learning how to do 4 operations. Inserting, updating, reading, deleting. So now add method is doing nothing but what? Adding an element into array structure. How easy it is. Understood? Such a powerful structure, we need the support of it, and already it is given to you in the library. You don't have to invent one. You just have to understand how it behaves, and that implementation is already done for you. So let's see what happens. So once when you create the array list, initially the array list will not have any values, empty it will be. Okay, so it will be a small object like this. It means it will not be having anything. Then I'll go on calling the methods. The first method I'll call now. So as soon as you call the first method, add, now what happens? C is added. So C is there now. Next what will I add? A. So this is how it starts growing now. C, A. Next I'll add what? E. Fine. Grows. Then I'll add what? B. Then I'll add D. Fine. See, it started growing now. As you go on, as the program goes on executing, the array starts growing now. Understood? Then next, I am adding a duplicate. Yes, it will allow. Then I am adding null. Fine, it will allow. Now you might think, why null? They will come dynamically from database or from user. Sometimes user will not enter any value in the UI, user interface. That time it will be a null value. Understood? So in from somewhere nulls will come. Don't worry. From where it comes, as you go on developing applications, projects, you will understand. Understood? So then finally I am adding 10. So this is how the value is getting stored. But the first question is, the rule of collections is what? Group of similar data. And on top of that, array means what? Group. Array is nothing but, array structure always holds what? Group of similar data only. Understood? But here we are seeing dissimilar data. Now why it is allowing dissimilar data is the question. See here, all the elements are stored in the superclass form of object. You are adding like this. Which is the mother of all classes or superclass of all classes? Object. So you can take string, you can take integer, anything you take now, all are subclasses of object. So that is why, yes, they all belong to one family now. It is allowing you. So that is the main reason it allows dissimilar elements. So this is one of your prime interview question. Why does ArrayList allow dissimilar elements? So all interview questions today. Understood? Why does ArrayList allow dissimilar elements? Because all the elements are stored in the form of object. Fine. So once you store it, yes, then they are stored in the superclass form of object. See, that is one way of adding an element. Now one more method is there. Notice. See, can add list dot add also. Yes. Now what did I do? Add is a method. What the operation it is doing? Inserting operation. But this method is not there in collection interface. Yesterday I didn't show you. So this method will come from what now? List interface. So almost all that method will be available to what? All the classes. So if you learn now, it will be helpful for you in what? Linked list. Because linked list also will have this particular method only. Same methods. So in one structure you have to struggle now to learn what? Methods. But once you get the grip in one structure, many structures will become easy for you. That is what is framework. Standard way of operating now. Clear? So learn in one structure, full effort you put now, automatically other structures become very easy for you. So this is an overloaded method. Now why did they overload it? Functionality is same now. What is the functionality? Adding an element. See this. If you want, you can check. ArrayList in Java, yes, you can go. So never read without documents. See, add. This method I am teaching you. More methods. We are only learning what now? Library, no? Are we bothered about writing logic? No. I want something to perform. We are checking out which method will help you now. What more do you need? In other languages, what do you do? Write logic, no? Here, what logic you are writing? Zero. We just want to use it. And I believe you know how to call methods, because you are all what? Computer science engineers. You know how to call a function, no? Same, call now. Okay. So calling function is that important now. But to call the function, there are two things. You have to send arguments now. What? Int. And one is element. Object it is. Understood? So you have to send it. So this is overloaded. But where did this method come from? See this, I'll show you. Util package we are dealing, and one is the ArrayList class, the other one is what? Okay, ArrayList is anyway opened, sorry. Now there is a list interface. Yeah, see, this is the extra method here, but it was not there in what? Collection. If you want, you can see in collection, which is the super interface of this collection. Click all super interfaces. So only one add was there, which I showed you yesterday. So that extra method was added in. So like that, what is extra, they go on adding in interfaces. Then these classes also sometimes can have what? Some more extra method. The hierarchy is like that. Always remember this hierarchy. Some methods, a common will be there, extra here. Some more extra methods will be in what? Class. It will not be in the interface. That will be particular to this particular class now. That is what is inheritance. Inheritance is always done for what? Adding or changing logic. So they go on adding now. Understood? So this is how you can understand inheritance. This is practical implementation of OOPS you are seeing now. Okay, means it is, you are seeing how they are using OOPS to build their built-in classes. Understood how they are using OOPS to build their built-in classes. Later on when you do projects, you will also be writing plenty of classes. There also you will be implementing OOPS. There you will understand very clearly, perfectly you will understand what is OOPS. So OOPS is not a subject which is learned in one day. Okay, it takes really many days to understand OOPS. You got the base of it, no problem. As you go on learning now, we are more practical in OOPS now. Till now we are theoretical about OOPS, but from now we will become more practical in OOPS. Done? So then that's one thing now. So add all, fine. So there are more methods. I'm just trying to explain you more methods in the library now, nothing else. So this is the overloaded method. Understood why they overload? When the functionality is same. Okay. So then next, after adding, but all this add method is actually doing what now? End of the day. Now what did I teach you till now? How to do insert operation. Yes, but more to focus on this method. See, once I added all the elements, this is how the array list started growing. The index is from 0. Okay. So now I am telling list.add. When I added this is how the elements got added now. So now I am telling list.add 2, p. So what happens now? In the second index, okay, add means it will add a value. And see here what happens. Here in the second index, it will get inserted. What is the value? 2. And all these elements will shift now. They are shifting. But it is possible to add an element at a specified index, which is not possible in array, primitive array. It is shifting, it is growing now. And now what is the difference between this add and this add? We know it is overloaded. Functionality wise, this add is adding at the end of the array. This add will add at the specified index. See, you go on saying add, now where it is adding? You just now saw I was adding at the end. And this will add at the specified index. Which one you want? You choose. The language is giving you support. Means Java is giving you the support in the library. Clear? Yes. After adding the elements, now you can check. Size will be what? Say, initially it was, they have shifted, you understood now? The index has changed. That's why I'm overwriting. Earlier it was different, now it has shifted. This is what is time consuming. Understood? No? So if you try to add an element in an array or remove an element from an array, it is time consuming and brings down the performance. Array is brilliant for read operations. Read, if you want to read only records, array is good. But if you want to do which one? Deleting, inserting and all more operations, linked list is good. We'll study that later. But anyway, I'm not saying that is better. I'm not telling ArrayList will not support it. It is supporting it. Okay. So you have to decide now. In your project, you got a scenario now. I want to do too many read operations. Go for ArrayList. I want to do updation and insertion operation. Deletion and insertion operation. See, too much of insert and delete. Remember, linked list. Read operation, array. Understood? That is what you have to understand. So, as you see more programs, you start getting clearer idea now. This is the idea about using a data structure now. So, it will be added. So, then it will be added at the second index. Fine. So, understood how to insert elements into array now? Using what? ArrayList. So, next we learned, see, we have to learn 4 operations now. One is inserting in primary memory. Second, we have to learn what? Reading. Then I'll show you updating. Then I'll show you deleting. These are the 4 operations we want to do in primary memory. So you hold the values. Now I'll show you how to do read operation. Reading is very simple. Look at the method there. Get. Finished. You want the element from which index? Third index, fine. So what is the element returned now? 3 means what element will be returned? E. Look at the array there which I have drawn. This is the list.get of third index. What is the element now? E. So but return type of get method is object. Okay, that you have to typecast. Why will you typecast? If you don't typecast, what will happen? You lose the subclass functionality. So if you want to call some methods, extra methods, now you have to do typecasting. Means if you want to call the methods of string, if it is of type object, you can call what? Only object class members. But if I typecast now with S1, I can call what? All the members. You know, typecasting. Okay. So this is one way to typecast. Same thing now. I'm reading a record only from which one now? 5th index. So this one will print E. This output will be something like E it will print, and from 3rd index this will be what now? D. But look, for all the classes now we do typecasting. If you want to convert object to integer, object to anything, we do typecasting. But only for string now there are 2 approaches. One is you can typecast, or you can call what? ToString method. We extensively use this only. So that's why I wrote both the syntax, and anyway string yes to. Now what the operation you are doing now? Read operation now. Finished. So inserting over, reading over. Next what? Updating. How will you do update now? Simple man. Set. Which index? 1. Q. So means what? In the first index, A is there now. It will be overwritten because you are saying set. Add will add. Set will update. Q. A was changed to what now? Q. Then that is done. After that you can print and see. Then next I want to remove. Fine. How will you remove? Yesterday only you saw. I showed you this method yesterday. But there is one more way to remove here. It is an overloaded method. You can remove with the index also. This method extra comes from list interface. Okay. Collection interface is having only remove method string or object. Okay. Here it is passing what? Primitive value. Int you are passing. Okay, so this is the extra method in list. So here you are deleting. So we saw how to update. Now we are seeing delete. But this remove will remove only single element. Now I want to remove all the elements. Clear. Yesterday we saw. Such simple man. Brilliant it is. A very powerful structure brought down to earth for the programmers. Understood? So that easy they make the life of the developers in Java. Okay, so let's execute this program and see the output. See first, after the array list is created here in this scenario, you can see what is the size? 0. Is empty is true, and elements, there are no elements. Are you clear with the first three output? Are you clear with this output here? Okay, we'll go with the next one. So we are adding what now? Diseliminate element, duplicates, all that, and we are also adding an element at a particular index. Okay, so after adding, what is the value? Size, same output I am doing. Size is 10, is empty is false, and now we'll see the contents. See, this is the output for that. See what I have drawn there, the same output you are seeing here now. See, first initially it is A, initial, later on it will be changed, A, then E, sorry, instead of P, E, B, D, F, A, null, 10, same way. Highly predictable. Okay, so then value present at index number 3 is what? E. After that, value present at index number 5 is what? D. See there, it's clear. Understood? So then, means this is our next output, what you saw. Value present at that. Now I am replacing, one will be replaced with what? Q. So that is why initially it was A. Now you can see it has been changed to what? Q. Then I deleted. After deleting, what is the size? 2 elements I deleted. One F and one more is 4 or something. So once I delete, what is that I am deleting? F and 4. So F is deleted. Now the array shrinks. This is only time consuming. It is expandable now. It can grow and shrink. Okay, but arrays are what? Fixed. Okay. So even though it is beneficial to us, but we treat it as what? Drawback. Understood? So I removed what? F. I can remove one more element now. Which one? I can remove either by passing an element value, or I can remove by passing the index. It's overloaded. So these two are deleted. So once it is deleted, now notice E, D, A and all will print, but these two will not print. See the output after deletion. So this were the original values. Now where are you seeing B and F? See this next output, and element size is 8 and size of clearing. Okay, clearing means all will be gone. So you saw how to do CRUD operations. Perfect. Any difficulty? Nothing, no. Just you should learn what here. How to call methods. This is true Java. True Java is all about what? Using library and calling methods, nothing else. We don't program in Java. And you will go on seeing now. Whatever you have problems in application development, you got only built-in libraries like this. Clear? Any questions? This is one sample what you are seeing of Java. Plenty is there. Clear? Any questions with this example? Done. Next. We'll go with more methods. That example I'll close now. Some more methods we'll see. Yeah? We are learning what now? Yesterday we learned the methods in collection interface. Today we are learning the methods in list and array list. That's it. Library. So I introduced one concept, and that concept is supported by what now? Some method. So see, we want some logic. Java says what? See how they are organized. I want some logic to be written. Java says don't write. We already written it. Where do they write logics? Methods. Okay, where are the methods kept? Classes. Where are the classes kept? Packages. What organization, man? Can you imagine how they are organizing? And for that, documents. And on top of that, Eclipse. Unimaginable it is. Okay, so fine. Next, let's see more methods now. Okay, list dot size, list dot is empty, list, you know this 3 output. Okay, initially it will be what? Sizes. Okay, one thing. So see here, I want to teach you more methods now. See in this array list. You're coming to array list. This is array list now. Yeah. See there are 3 constructors. Array list is having. Till now we are using what? This default constructor. Now I'll use this constructor. Slowly you'll understand all this. So here if I create an object with using this constructor, what will happen? It with some specified size will be created now. Capacity. Okay. So that's it. So generally we don't use this, but just I'm explaining you the library. This is the support what you have got. Maximum we go with this only. Because here what happens when you create now? An array list will be created with that much capacity and waste of memory. For you memory is the major issue now. Yes or no? If I write int I, what will happen? Sir, 4 bytes will tell. So here also memory problem only. So that's the reason what will you tell? You will not use this. Generally we go with this itself. So yeah, but I'll show you for the demo purpose. See this. First I'll be showing you that. See the first constructor. I'll remove that. Yeah, now you see. So I'm going to create an array list what? Size of 15. After creating it 15, then I'll add all the elements. Then I'll print what? All the values. That's it. Nothing more I'm doing. Just I created an array list with some size. Let's see the output. Let's see. Initially size was 0, is empty is true, then this one. Then I printed. Nothing I done. Just I'm printing here. These 3 printings before and after I'm doing. This is before adding values. This is after adding values. Done. So I can do. But see, size is 9 only. Capacity is different. Size is different. Size will always give you the number of elements. Okay. So if you have doubt, don't by heart. What do you do? Document. What does the size method do? Check. Size returns the number of elements. Document is telling you, refer to that. You don't by heart. Understood? So capacity is different, size is different. Capacity means a big array was created. See here what has happened is when you executed this program, one empty array list will be created now. What? With what? 15 capacity. And there you are adding what now? Values. What are the values? You just know, so whatever I am adding now. Okay. So already one array has been created. Then you are adding values into it. Still what is there? 6 will be empty now. Waste of memory now. It's a size of 15. But you have added only what? 9 values. So 6 are empty. So waste of memory. Understood? But it is possible. If you want, you can create an array like this. Now one more question to you now. What happens if I add more than 15 elements? Means if you have got an array with some capacity and if I add more values, will it grow or will you get an error? Use some common sense, it grows. Because we can't, so the purpose of this is, see, I'll just make the size to 50 instead of 15 to what? 5. But we are adding 9 elements. Well, that means I'm adding more elements. So it will grow. First, initially it has been created with what? 5. Size is 0. Is empty is true. No elements. But 5 capacity. Capacity is 5. I'll add more values. After adding, what has happened? It has grown. Understood? So very simple. Yes. So like this, these are concepts. These are concepts what you have to understand. Understood? So more concepts, you know. When you develop applications, you'll come across various problems. Then only you'll get the idea of using all this. Okay, done. So then next, I'll create it with what size? 15 only. Yes, no problem. But later on I realize I'm wasting what? I've added only 9 elements. I realize I want to remove that extra space. 15 is there now. But I added how many? 9. Only 9. I want to remove those 6 extra spaces. There's a method, trim to size. That's it. All you have to do is what? So we are learning how to use the methods in the library. That's it. Nothing more. So trim to size, what does it do? Trims the capacity of this array list to the list's current size. Whatever size it is. API document man, trim to size. Don't trust me also. I will tell that. Okay, document is there clearly released by what? The inventors. I'm just presenting you it. Nothing more I'm doing. Understood? So trims the capacity of this array list instance to the list's current size. So what is the current size in our array list? 9. It will remove. Means that 6 empty spaces will be removed. That's all about trim to size. So we learned one constructor now. We learned one more method. That's all about learning how to use every method. Understood? So for that example to prove what we do, for that concept, to make you understand that method, what will I do? I'll build an example. You take any book in the world now. You take any book. They are also doing the same. Nothing more they are doing. This they'll read, they'll design an example, they'll be printing it to you. That's all Java is all about. Here, initially up till packages, yes, they can give their own explanation. what is overloading, what is overriding, what is class, what is subclass. But once package concept completes, package is there now. We completed package in how many classes? 40 classes. Okay, that's it. That's the end of Java. After that only library. There's nothing. Java is not a big subject at all. Language wise, if you see, it is small. Library wise, you see, it is huge. Understood? But other languages also, they are big. Language wise, language means the support now what they give. So all that is big. Apart from that, you have to write the logics also. So understand first the language, then you'll start understanding all this support. Clear? So done now. Trim to size. So yes, but after trimming also, size will be what now? I've just added 2 more print statements, nothing more. See the output. Same it will print, only 2 extra output are there. See, after trimming, size is still what? 9 only. Only that extra space has got removed now. And the elements remain same, unchanged. We didn't do any operation on that. I only removed what? The extra space. That's it. Clear? Fine. Okay, more methods we'll see. Okay, we'll bring it back to the original style. Which one? Without capacity. We generally work like that only. So I just showed you that, and I'll comment a list to trim size now. This method. Yes, we'll go with more methods now. A list dot index of b. I want to find out the index of b. Fine, method. You want to find out what is the index of a particular element. Fine. Then let's print now. What will be the index? CAEB. This will be 0. This will be 1. This will be 2. Just I'll draw this array for you here, because we are studying that. So this is your array now. You added these many elements. After that, and I'm not using capacity this time, I want to find out the index. Okay, the indexing goes like this now. 0, 1, 2, 3, 4, 5, 6, 7, 8. What will be the index? 3. See, index starts from 0. Total number of elements are 9. Okay. Only one line. You see the output now? Yes, see, this is before adding elements. This is after adding. What is the index of B? 3, no? You can see it here only in the output. CAEB, third index. It starts from where? 0, no? Index of B, man. 0, 1, 2, 3. Index of B is 3, that's it. But that's a method now. So that's what is library. So next, don't focus on output, understand concept. Okay, concept is this: I want to find the index of a particular element in ArrayList. That's the concept. Solution to that is what? Index of method. I have a question.
So there are 2 duplicate values. Then how many index?
First value it will give. There are more methods. Last index of first index. So we'll see that. Okay, just it's giving you. Your question is, if I have duplicate values, which index it will give? First index it will give. Okay, we'll see that also. This is just introduction. Understood? So then, now see, we'll go with the next method. Brilliant method it is. Can you guess what will happen? See what is happening. See, this is one array list I have created. List. This is one object. Understood? Which is having so many values. Now the same values I want in another array list. Can you sit and copy one by one? You don't have time. Correct? 6:30 you want to go home. Office timing, no. Government timings, job. So what will you do? That's why Java gives you library support. So what you do? Just call the method clone. I told you all collections are eligible for cloning. That is one point we discussed. So as soon as you say clone, what happens? One more object is created. The variable name is another list. Don't bother about that. This is a variable name. It's of type what? Means the return type of clone is object. Typecast it. The return type of clone is object. Typecast it. And array list. This is another list. So one more object is created with what? Same ditto values. Understood? Same ditto to ditto. Same values will be there. C, A, E, B, D. You're following now? Yeah? So this is how cloning will happen. Clone means it will have one more copy of it. That's it. Means one more object will be created which has the same values. Yeah? In fact, if you have to understand clone, there is some more things to, just this much is sufficient for your information, but little extra information I'll give you. Fact is, when you do cloning now, in fact here values are not stored. What is exactly stored? References are stored. Here also the same reference value will be stored. Understood now? Here also same reference value will be stored. Here supposingly C is having an address like 101. Same value will be copied here. That C value will be somewhere. C value is somewhere, but the same reference value will be copied. We'll discuss on that, but just understand cloning now. Clear? Fine. That is called as shallow cloning. Shallow cloning means just copying the reference. Okay. So that is done now. So let's see the output. See in another list, what is the value? Same no? Contents of another list. What am I doing? Size is also same. Size of another list, size is also same. Values are same. That's it. Okay, more methods. Now I want a sublist, means some range I'll give. From so and so range to so and so range, I want elements only between that range. Fine. One more list object will be created and returned with only how many values now? From second index till fifth. Fifth is not included. From second till fifth. Document, read document. What does the sublist method do? Understood. From 2 till 5. 2 will not be included. See the output. See, this is the original value, but this is the values of sublist. And one more output I got. Value of contents of array list. It doesn't mean that all the values are removed from there and copied here. That value is there only in list. From there it has been copied into sublist. Understood? You have got in the list also means I am printing here too. Value in sublist are values of array list are. It's not cutting and pasting. It will copy. Clear? Okay, that is sublist method. Are you clear with all these methods? More methods. So means when you are working with arrays, no, these are the common problems what you get. These are all the problems what you face. See, when you are working with primitive array, you want to create a sublist. You want to do copy from one array to another array. Understood? And you want something like this. So that time what will happen? You want to find out the index of a particular element. In a primitive array I am talking. Who has tried the logic there? In a primitive array, see these methods what you studied now. Index of, clone, sublist. Okay, all this logic who has tried in a primitive array? You have tried. That's what they said. Don't try it, use this. Clear? So fine then, this is one more. Okay. Any questions in this example? And you don't have to worry. As you go on using now, you will understand it perfectly. That is library now. If I am writing any logic, if I am inventing something, there is something to teach. There is nothing to teach here. Only we are discussing about what? Library, library, library. So as you go on coding, your doubts will get cleared. You don't have to worry about it. Literally zero doubts you'll have as you go on coding. Here you got, fine. Then we'll use the same technique in what? Projects. This is theoretical. There you will see practical. So when you do projects now, things will become more clearer and clearer. When you do projects, when you do practical, means applications development and all, it will become more clearer to you. So you don't have to worry more about that. Okay, now the next example, we'll see how to store primitives now, or how to work with primitives in ArrayList. Very simple. I think you should be able to understand now. You have to do what? Boxing. Clear? So I'll show you how to do CRUD operations with ArrayList using what? Primitives. Here I am doing what? Inserting. We can insert like this also now. 2 comma what? New integers. So here what happens? Just see now. First ArrayList will be created. First value will be added. 102. Then next value. Which one is added? 104. Then next value. 101. Then next value. 105. Then next value. 103. Yes. The index starts from 0. But you are clearly telling, no, I want in the second index a value called as 222. It will insert in between. Fine, no problem. So in the second index, what is it now? 101. So that will shift. Means in the second index, what value will come? 222 will come. What was the value here earlier? 101. Yeah, that will become. This is second index. This is third. This becomes fourth, and this becomes fifth. Simple. So then you can print size, list, yes, fine. Now you can calculate the index. New index of what I am using? New integer of 101. See how I am working. The return means index of argument is of type what? You have to pass index of, if you look at the document, index of tells pass an argument of type what? Object. That's why earlier in giving double quotes I was giving index of E, index of B, is we are finding the index now. So I am passing as object. See how you work. So see, this is how it works. Okay, fine. Then next, list dot index of. It will not give you. You are giving it as what? String. Even the value is correct, you will not, because it is treating this as string value. Understood? So be careful when you search. Okay. So then anyway, this is the index of. Then you want a value from the third index. Get. I'm showing you how to do CRUD operations. Get of 3. Return type is what? Object. Typecast it to what? Integer. Because you want to call the methods means you have to typecast. You can also means I am getting one value from third index, one value from fifth index. Fine. Then I want to replace. So in the first index, what am I doing? I am placing a value called as 111. It will overwrite. 104 will be overwritten with what? 11. Set method replaces. Then remove, you know. I can either go with the value or I can go with the index. So that's how you can do CRUD operations. But this is with primitive. So yes. First, how many values I added? 6. And this is the content. First it was what? 104 is there. Okay. Then index of 101 is 3. Index of string 103 1 is what? -1. Means the index of method, what it does is, if the element is present, it will give that correct value. Else it will give what? -1. If the element is not present in that array, it will give you -1. So if for this one it is giving you 3, but for string it is giving you what? -1. Means index of I, index of j, int I is equal to list dot index of. So index of integer 101 is plus I, it is 3. List dot index of 101 double quote string, so it is -1. Clear? Then fine, you want to read a record. See, one I can go with index. Yes, we are going with index 3 and 5, and the values present in third index and fifth index are what? 101 and 103. Correct? Then I want to replace 1 comma new integer of 111. So what happens? In the I think we deleted after that. No, yeah, we are updating it. Yeah, after replacing. See, after replacing, what is the value? See, before value is 104. After replacing it is 111. Now I will delete. What is the size? 4. And these are the values. So this is how you are working in 1.4. So working with primitives in collections was a big headache. So they relaxed it in 1.5 by introducing what? Auto boxing. You know, that is one more feature, one feature which was added in 1.5 version. Up to 1.4, from 1.0, 1.1, 1.2, 1.3, 1.4 version Java, you are adding elements like this, which are primitives. So see here, nowadays, if I say, see, I want to add an element, no need of telling like this. What I can do? This will also work. Why? Sorry, let's start add of 102. So I'm adding like this. Fine, works. It is auto boxing to support that. So auto boxing feature, when you saw it was something odd, but now you can see how beneficial it is. So whatever the language gives you, remember one thing, it is for your benefit. Nothing there. See, if a language makes something complicated, nobody will learn it. First thing you understand that. If a language, if any language is complicated, no, you will not learn that language only. Understood? So I can add like this. So, or if you want, I can see here index of. I can check like what? 101. Like that you can work now. Same output you will get. But right now, when I am teaching, I will be teaching using what? 1.4 syntax. Understood? But you understand this point. Means if I tell you, you will definitely go into R&D. I will tell collections do not allow what? Primitive data. So definitely try to do it. Okay, some R&D will try to do, and you will tell, come and tell what? It is happening. Remember, we are using 1.6 version of Java. That is why it is allowing you. Understood? Try to install 1.4 and check. It will not work. Clear? 1.4 or below. So any questions here? Primitives? Done? Yeah, now the major subject will start. So now we saw how to store exist, means built-in data types like int, string and all that. Okay. So now we'll see how to store user-defined data. User-defined data, that is very crucial now. Now your user-defined data means what? That also, why do you build on user-defined data? Same reason, to hold value. Understood? See this. I want to hold some values related to one entity. See, look at the folder structure. I got here one more package called as com.cluster.user-defined-data. In this package you'll find that example. Earlier examples were here. Now the next example what I'm showing you here. So in this package I got one class called as employee. Look at this. So this is how you build user-defined data. So when you retrieve the data from this database, whatever one value is there in one row now, you'll have one row now. Okay. So all the values from there, means one row is nothing but what now? One entity or identity. Those values from the secondary memory, you will not store it in single variable. It's a common practice to store that into one user-defined data and organize the data. Understood? So see here, this will be your table. Example I am telling now. You will have employee ID, this is your table. You will have name, and you will have phone, and you will have email. And you might have values. Some name like Ravi, phone 111, email ravi@cluster.com. Like that, more elements you'll have. Okay. And now see, user will be asking for something. You will connect, fetch values. So there are 4 values coming now. I can use 4 variables now. Yes or no? I can use 4 variables. One int, one string or something like that I can use. 4 different. One employee, okay. 2 employees you retrieve. 3 employees you retrieve. Now headache will start. You will not know whose value is stored in which variable. Now when you don't know whose value is stored in which variable, how will you process the data? So this is where complication starts. So once this complication starts, okay, so what we have to do now is Java gives you a better solution to this now. Java goes on to give you a better solution. So let's see how they'll do it. Means we go for user defined data, simple. We design like this. So the first time you're designing some good class. Okay, so what's the name of the class? Employee. Not only here from database, sometimes you'll have UI also. In the UI, user will fill all the value. ID, name, phone, email. So like this also values will come. It might come from user interface or it might come from database. This is what an application is now. Okay, so obviously you have to store the data into user defined. There is no other option for you now. Okay, so now see, if it is single employee, I'll store it in one. I'll create one class like this and I'll store it. But when there are many employees, now it's very interesting. It will become what? Array list of employees. Till now you're adding what? Simple string and all that. This is the actual, I'm talking about practical scenario now. I'm not talking about theoretical. Till now whatever you learned about array list is what? Theoretical. But practically in an application, this is how array list will be used. So practice more on this example. Clear? So yes, now your user defined data. Coming to the design of your user defined data. Okay, so see here, this user defined data is having what private properties. Look at the class now. So this class is called as a TO. First understand the user defined data, how they have designed it or how we are going to design. Okay, first understand this. Adding in array list, you know, it's very simple. But let's understand the design of it. Okay. So this kind of a class is called as a TO, or it is a full form of that is transfer object. Understood? TO, we call it as VO, we call it as entity, we call it as POJO, all mean same. Some scenarios they call it as TO, some scenarios they'll call it VO, you'll understand with experience. But meaning of TO is what? Transfer object. Meaning of VO is what? Value object. Entity fine, means it will represent on row in the database. Or POJO means plain old Java object. That's the full form. Even though there are 4 different names, you don't have to worry, all mean same. Okay. So for storing our data, we start designing user defined data like this. So what we do, see, I can design my class like this. Class employee. See how we design. Plain old Java object. Okay. See, class employee. I'll have int employee ID, string name. Generally a phone number also will be of type string only, even though it is numerical. See, if you are going to manipulate the integer value, then it will be of type integer. Phone number will never be manipulated. Like see, there is some account balance. You will try to add, subtract, some kind of operations you do, then you will be using it as integer. If you are not going to manipulate it, pin code, phone number, they will generally be stored as string only. So fine. So string phone, string email, you will follow all conventions, you will understand. I have designed the class. Okay, now to see, these values, as I told you, they come from UI or from database. Yes, will come. So when they come now, what do? You create objects. Employee E1, whatever name you want is a variable name, is equal to new employee. You can design a class. What is that? Brilliant class it is. And now I'll fill the values. E1 dot ID is equal to 101. Remember, they come dynamically. I'm hard coding now. E1 dot name is equal to Ravi. E1 dot phone. Put the heading as TO actually. Put the heading as TO and write the notes. Okay, put the heading as TO and write the notes, all this. Okay. E1 dot phone is equal to 111, but in double quotes. E1 dot email is equal to Ravi at the rate of cluster.com. This is how you got your TO now. I can fill. Later on, if I want to use, how will I use? This is storing. An object has got created now. So as soon as I tell that This is one object. It will have the variables ID, name, phone, email. So when I create the object of employee, what will be the default values? ID will be 0 because it's int. All these are string, they will be null. So they overwrite and the values will be filled now. So 101, Ravi, phone is 111, email is ravi@cluster.com, something like this, it will be there. Values are there. Next, I want to use the value. How will you use? No get, still get is pending. So you have to get like this. See, you will be getting it like this. Int, if you want the ID, int A is equal to E1 dot employee ID. Yes? It's something like how you work the box. Int I is equal to B dot W, int J is equal to B dot X. You're getting the value. Why? To process. Understood? Then string S1 is equal to E1 dot name. From there it will be copied into this variable like that. You can use it. So storing is fine, using is fine, brilliant, no problem. But again I can overwrite, no? There's one chance here, no? It is vulnerable. Your data is getting, you see, we talk about encapsulation. What is encapsulation? It's the process of hiding data so that only required methods can use it. That's what is encapsulation. Yes or no? We are saying oops slowly, we are saying oops now. Fine. It will overwrite now. Can you imagine data getting manipulated? Can you lose the data? No chance. So that is why we have to design it in such a proper way that data will not be manipulated. So what we do, that's why we make it as private. This is how you design it. But once you make it private, how will you fill the value now? That is one more headache. You cannot store only, no? Forget accessing, because when you cannot access that variable, how will you store it? That's the next question. Okay. So due to that, what happens? We design this class in such a way that we'll have some methods to store and some methods to retrieve. And those methods are called as setter getter methods. Generally we call it like that, setter getter methods. Setter method means it will set the value. Getter method means it will give the value to you. That's it, nothing more. Understood? So what we do now, see here, only one I'll write for name. This will be public method, public void set name. This is the convention what we follow. You should not use M1 method, M2 method, no. Understood? So you have to use public void, return type will be void, and parameter will be string, because it has to store into that. And here I'll tell this dot name is equal to name. Why? Because there is a conflict between local variable and instance variable. This is for name. Similarly, you'll have setter methods for what? Updating. All the four. How many variables are there? Those many setter methods you'll have. Okay. So instead of filling the value like this now, what will I do? After creating the object, employee E1 is equal to new employee. E1 dot set name. Now this is more better. This you'll call this method. This method will put the value into. This is set name method is there now because you added now just now. Whatever comes, it will be filled here. Like that, you'll call the setters. Fine. Storing is okay. How will you get it now? So we have one method called as getter. Look at the naming convention. What brilliant it is. Java follows this convention. Public return type is what? String, and here you do what? Get name. So when you look at the method name only, it will tell you what it is going to do. Set the name, get the name. And here I will say return name. Return type is string, but no parameter here. You know how to design your methods now. Arguments, parameters, return type. Yeah. So that's how it is done. This is for one method. Now what happens? We create the object and start filling the values like this. Okay. Remember, there are 4 ways you can initialize your instance variables. Never forget that in Java. One is hard coding. Second one is dot operator, which I just now showed you problem. Third one is method. Fourth one is constructor. Sometimes we take the help of constructor. Sometimes we take the help of methods. I told you long back. So right now we have started using methods to store the value. But here only one single method will not store all the value. For one variable, you'll have one method. Understood? You can't have a single method. Why means you will never know when all the values will come. Sometimes you'll get only ID, sometimes you'll get only name. Supposingly I write on method void m1, what will happen? You have to send 4 values now, but you have not got only now. So in a single method will not fill. So what we do? We start using for one variable, one method. So sometimes we see, I'm telling both are used. Sometimes for initializing the instance variables we use constructor, sometimes we use method. But method names will not be arbitrary. Arbitrary means some names you give very usually like m1, m2, fun, show, wrong. Okay, which they are called as arbitrary methods. If at all you want to store values, you give what? Setter, getter methods we say. So these are conventions what is followed in industry worldwide. Now I am not teaching you all this now. What is there in industry I am telling you. Understood? So this is how you have to do it now. So are you clear with this now? So this is how you will design your TO now. Finally, what is a TO now? A TO is a user defined. I am designing it. Write the notes. A TO is a user defined value object which is used for storing and a TO is a user defined value object which is used for storing and transferring values from one method to another method. Write like this, from, I'll clear here, from one method to another method. I'll explain you this point. To another method. 2, you might send it one method to another method, or slash you put one method to another method. I am not having space, just you write another method slash one layer to another layer, means or, slash means one layer to, or slash means or, one layer to another layer, or one, look at the spelling, tier, T-I-E-R, tier to another tier. You followed now? A TO is a user defined value object which is used for storing and transferring values from one layer to another layer, or one method to another method, or one tier. So these are project terms which you'll understand late. Understood? So next point you write. TO has private properties. Property is nothing but instance variable only. Here they call it as what? Property. Okay. A TO has private properties and public setter getter methods. Public setter getter methods. Now always write setter getter like this. We will be using this word. Setter getter, write like this. A TO has private properties and public setter getter methods. Understood? See, this is one of the design pattern. Again, this is one more design pattern. What is the design pattern? You know, no? Right. It is one of the design pattern which is used in the development of applications. It is one of the design pattern which is used in the development of applications for storing and transferring values. Now I will explain you what is that. It is one of the design pattern used for storing and transferring values. From where to where, you know, no? It is one of the design pattern used for transferring values. From where to where? From one method to another method, one layer to another layer, one tier to a tier, like that. Okay. So now, see, storing you understood, retrieving you understood. Now you are not understanding the word transferring. Understood? Means what is the meaning of transferring values from one method to another layer, one layer to another layer? I'll show you. See, generally values will come. Now all these values you want to send it to one method. Yes or no? See, Java programming is all about what? Writing logic. Now all logic you will not write in one method. Yes or no? You will write it where now? In many methods, and one method will call another method. Okay. But when one method calls another method, the logic is there, but value is where? You have to send the values. So you'll be sending arguments. Supposingly, now there's a scenario that there's one class called as hello. I want to send this 4 values to this hello class. Okay. So there's one method called as m1 and I want to send this 4 values. So yes, look at the signature of my method now. Int employee ID string name comma string phone comma string email. You have to keep it like this. And supposingly there's another method now which wants to send. Right now I'm taking main method, so it will say now hello h is equal to new hello h dot m1, and you have to send all the 4 values 1, 2, 3, 4. Understood? So this is how it happens. Okay. So see, the scenario is simple. You are getting the values from the user interface. From the user interface, you are sending the values to one method to store the values into database. Okay. So you got, see, this is the scenario now. Where I'll remove this class now. See, this is a demo, and there is one class called as hello, which will, see, I want to insert the database, these values into database. You have got them now, so you will get it now. Dynamically you will get it. Initially they will be there in variables like this: int a, string s1, string s2, string s3. So what will you do now? You have to create the object hello h is equal to new hello, and then you'll say h dot m1, and you have to send a, s1, s2, s3. Now m1 method will receive the value, and here you will write the logic to insert into database, right? That's how it will happen. But the thing is, okay, tomorrow one more column I'll add. Example password. In the user interface also, earlier having only 4 fields, but now one more will be added, which is that password. So it comes into your application. From the application again it has to go to what? Database. Perfect. So in your program, what you will do, you will increase one more variable, string s4, for what? Password. That is okay, you will accept it. But how will you send now? You have to change your parameter now. What you have to change now? String password, you have to change one more. Imagine changing the signature of a method. Dangerous now? Because see, till now you are learning classes. In all the classes you study the method only once now. After that you'll never bother to read that method. You learned so many methods just now. Tomorrow they change the signature of the method, how will you use it? So nobody will manipulate. These are the problems. Okay, so the scenario is very simple. I want to carry multiple values from one method to another method. That is all my requirement is. Where in projects this problem will come. So that is why instead of sending values like this, we put all the values into user defined data type. Just now I showed you now. Employee. Brilliant support now. Don't have your signature like this. Your signature will be what? Employee E. Finished. So here what will you do? All the values you fill now. Employee E1 is equal to new employee E1 dot set ID. What is argument? A. E1 dot set name. What is argument? S1. Fill all the values. You got now 5 values. Fill it. And then you call h dot m1 and send your employee. So here what will you do? You got the values. Call it now. E dot get ID. Getter methods. So there you will say set. Here you will say get. Easy now. Whatever values you want you are getting. And now it is what? Call by reference. Pure call by reference. This E will refer to the same object, and this is the idea. So why do you use user defined data for storing values? So that you can store multiple values, and sending data will be very easy for you from one place to another place. Understood? E dot get ID. See, that has come now. E dot get name, and all this you are going to see practically. This is not theory. You are going to do it with database. E dot get email. That's the project. What you are going to do. Done. So like that you'll get all the values. Okay, so here you say set, means when you want to put it you'll say set, when you want to retrieve it you'll say get. After retrieving all the values, what will you do? You'll write the logic to insert these values into database. Simple. So like that you transfer. I told, and see there are 3 points I told, from one method to another method. I explained to you method to method. Now the other 2 things, from one layer to another layer, one tier to another tier, you'll understand only in projects. Here I just told you what is the advantage of using a TO. Are you clear with the TO now? So this is a common recurring problem what you face while developing what? Applications. So that is why, see, whenever you have a problem, you use what? Design pattern. We have already seen one design pattern. What is that? Singleton design pattern. We have seen one singleton design pattern. So one more design pattern what you are seeing right now is TO design pattern. Understood? So design patterns are used for what? Means what is a design pattern? Whenever you have a problem, that design will give you a solution. Understood? So my problem is what now? Write problem. Actually you should have written it on the top. Write it on the top only. Problem. You have put the heading as TO now. There you write problem. I want to carry multiple values from one layer to, I want to store and carry multiple values. I want to store and carry multiple values from, yes, continue, one method to another method, one layer to another layer, one tier to another tier, same story. That is your problem. Solution is what? Use TO design pattern. Simple. That is the problem. Next line you write solution is answer. Yes, use TO slash VO slash POJO slash entity design pattern. All mean same. Understood now the problem? Understood the solution? So always understand problems, then only you will understand the solution. You will never understand a solution if you see it directly. If I tell you I am writing class employee and having private properties, segregatory class, why? That's not the way to learn. You should know the problems first and then automatically your solution becomes easy. So this is the reason why we do it. So this is fine. But now when you have multiple employees, just look at the scenario now. Shall I clear all this now? Okay. So this is how we'll be doing it. And now, so you have to write private properties and you have to write segregator methods. So if you want to write segregator methods, don't sit and type in Eclipse. They are shortcuts. Just if you do something, automatically the code will be generated for you. If you code in Notepad full day, will be typing what? Setter, getter, that one will do. So that's why you have to move on to Eclipse. There are many institutes which teach you only on what? Notepad Edit Plus. You cannot do it. Practically ruled out. Okay. So one is you should know how to use Eclipse also, and you should know all the features of Eclipse also now. So simply knowing what? Right click new project is not Eclipse. Understood? Now start seeing more, so you'll start seeing the power of Eclipse. See, anyway, just write this class employee. Okay, after writing it, what will you do? See, all you'll do is leave this toString method. See, this is how you'll be having your class. It looks like this. Getting it now? Private properties. Just right click, source, generate getters and setters. You'll have the option select all. Means whichever one you want, you can select individually or say select all. Public access specifier is what? Public. Finished. Automatically code will be generated. Okay, so it took some space here. Second. Yeah, see now. Right click, source, generate getter setters, select all. Okay, that's it. Your segregator methods are ready. Set employee ID, get employee ID. Don't sit and type. Eclipse is very helpful for you. Understood? Setter getter, set name, set phone, get email, set email. Here on top of that, I'll just override toString method. I'm just overriding. You will understand why I'm overriding. You know what is overriding now? toString we are overriding so that I print some message. Nothing I'm doing. String s is equal to printing just all the values. Employee ID is, phone number is, name is, overriding toString method, and I'll return yes, because the return type of toString is what? String. I'll prepare on string and I'll return it. That's it. So employee class is ready now. Next, see here. Storing user defined data. I created an employee. What is the value? 101. So see here, employee E1. See now, employees are getting, objects are getting created. See, I think, remember that they are getting from database. You are retrieving these values from database. See, there is a scenario like this. I am telling you. Now there are some employees. 101 is Ravi, 102 is someone, 103 is someone, 104 is someone. So these are the values. Okay. So once these values are there, Ravi, then employee 2, 102 is Kumar, employee 3 is Amog, and employee 4 is, 104 is Vinay. Some values are there. They'll have their phone number and they'll have their email ID. Don't bother much about them. So you'll retrieve it. Scenario is this. See here. You got on UI. It says you got a link here. Display employee and all details. You have to display all the details now. So this request will come to your application. You have to connect to database. Here you'll write a query. What you'll write? The favorite query you'll write. Select star. All values will come. You'll mention the table name you'll get. But all these so many values you got now. How many you got? One row, 4. Like that you got 4. 4 employees, 4 rows. Sorry, 4 columns. Who knows if you are having 100 employees? Who knows you are having 1000 employees? So all these values will come into primary memory now. From secondary memory you brought it into primary memory now. So now what we do? One row we'll put it into one TO. That's how you organize. But when there are so many TO, what will you do? All those TOs will put it into what now? Array list. Otherwise, how will you handle so many employees? So like that, it goes on mixing. Okay, you'll build using primitive, you build user defined. Using user defined, you'll make one array list. Like this it goes. So finally, see, you'll do it. Objects will be created. Okay, so all these employees will be displayed here now in UI. Like this. Same thing what you're saying. Employee ID, name, phone. This is what is writing an application. Nothing else. You want to write application, huh? When you click it, that will be displayed here. What more is an application? You take any application in the world. Which application you know? Any application in the world you take. It's all about doing CRUD operations with database. Nothing more you do. Only domain logic will come extra. Understood? You take Gmail. You click one button. What it will do? Either it will insert, or it will update, or it will delete, or it will read. That's it. Nothing it will do. Any application in the world you take, it's all about doing CRUD operations. Only domain logic will change. So you have selected and automatically you have to display now. So these values you have to store. Okay. So we have completed database. We are learning data structures. One thing is pending. What? How to connect to database from Java application. That is the next subject. Which one? JDBC. So that's how the course is going on. Link it is. Understood? So we'll do it. So now what we'll do? We'll create the objects now. Are you getting the idea of this? So we'll fill the values now. How will you fill? Employee E1 is equal to new employee. Employee E2 is equal to, see I got the values. So E1 is equal to new employee. After creating the object, what will you do? E1 dot, you'll call the setters. Then what will you do? Employee E2 is equal to new employee. E2 dot, you'll call the setter. Practically if you see, this is how the objects will be. E1. This is employee object. So it will have ID, it will have name, it will have email, and it will have phone and email. Sorry. Then you will have one more employee. ID, phone, 4 employees now. Sorry, name, phone, email. ID, name, phone, email. Okay, I'm writing 3, just understand. So the employee ID, so for employee E1, this is E2, this is E3. 3 employees are there. Employee E1, E2, E3. So they'll have their own address, 101, 102, 103. One more if you want, you take E4. ID, name, phone. See, we are seeing the practical implementation of ArrayList. Practice this a lot. Understood? Very important. So here, first employee, E1, ID will be 103, Amog, and his ID, this one. See, employee object is E1. Don't get confused. Object is E1, but his value is what? ID is what? 103. Deliberately I am doing it. Okay, E1 is having what? ID as 103, like that. Anyway, you can see that's an object now, just you have created. You don't know, you'll retrieve the values and you'll be storing it, that's it. So now this employee 2 will having what? 101, Ravi. Employee ID, this one, third one will have what? 104, and his name is Vinay. And this will be 102, and his name will be Kumar, like this. So yes, you have stored. Brilliant. No problem with that also. But now all these 4 TOs I want to send to another method now. Now you tell how will you send. Understood? These 4 TOs are there. Like hello M1 method is there now. It will process all these values. It will display it to the user. But how will you send those many employees now? You can't send. Because now it is 4, tomorrow it becomes 10. You have to specify the parameters you are now for displaying. You have to specify how many you display. One parameter means employee E1. This will be a parameter. Employee E1, employee E2, employee E3, employee E4. Practically impossible. Because more employees come, you can't specify the parameter now. What will you do? Now you need collection support. Fill all the values into collections. How will you fill? See, ArrayList AL is equal to new ArrayList. Do it. And you'll say AL.add. What will you do? This is class demo. You got the values. So you'll say PSVM ArrayList AL is equal to new ArrayList AL.add. After creating add now, E1, E2, E3. So this is your code, but practically what's happening? 4 objects have been created, and one ArrayList gets created like this now. Means slowly it grows. In the 0th index, it has the reference of what? The first employee. In the second one, it has the reference of what? This is your ArrayList now. 0, 1, 2. This one will be stored. Here 101 is there, 102 is there, 103 is there, 104 is there. This is your employee. This is ArrayList. Now you say hello h is equal to new hello h dot m1 and send your ArrayList now. Finished. So in M1 method, what is your argument now? What a brilliant approach, man. Unimaginable Java support. How you are handling data here? Which language will give you so much support, you tell me, for handling data? And that too at the simplest, because in C language if you want to do this, you deal with pointers. Here no pointer only. It's all about what? Reference. E1, E2, E3. Reference value you say, that also is hidden. We just add what? AL.add of E1, AL.add of E2. Till now you are adding strings. Till now you are adding integers. But now we start adding like this. And now here you will process. That I will teach you how to do. So here you will visit all the elements, retrieve it, process it. Whatever you want, you can do it. So like this is the actual thing what happens in projects. So you have your TOs, the values will be filled into TOs, the TOs will be again put into ArrayList or linked list, more is there. So you learn in one. It will be easy for you in what? All the structures. In every structure it will be easy. Okay, so after creating these TOs, you can store it in linked list or tree set or hash set, anywhere. You have to struggle in which structure? One structure. You struggle in one structure, automatically it becomes easy in any structure for you. Understood? And here I have written it theoretically for you. We are going to do it practically, nothing to worry about all this. With code only you will be seeing it. Understood? And you will do, not me. You are going to code. That is your ability now. Understood? That is where the difference stands between cluster and other institutes. ArrayList they will finish in one day. All data structures they will finish other institutes in what? One day. But it's a vast subject. Understood? It's a vast subject because we are dealing with data. Clear? So are you clear with this? So this is how it will happen. Okay. So just it will be storing the addresses, and once I get here, you can process all the values. So you'll retrieve all the values and process it. So today we'll end up with this much. Just store values in which one? Employee, put the employee into array list. That's it. Processing and all we'll do next. Shall I clear all this now? Okay. See, one more thing you have to understand. If you want to display select star, you will take this approach. Remember now. If I want to display only names, what will I do? I'll retrieve the values and put it directly in array list. Now you don't need TO. Okay, if I want to display only names, you will, what is your query now? Select one column, name. That's it. You got only names. Till now what you are doing, do that. al.add of what? All the names. al.add, al.add, al.add. So you'll be mixing, means sometimes you'll add only strings. Sometimes you'll add what? User defined TO like this. Sometimes you might want some pin code or something. That time you'll add only integers. Example I'm telling. Or balances, account balance. That time you'll add only integers. So all is possible. So you should, that is what you have to judge now. And this comes with experience. So until and unless you code, you will not understand. Means code means what? Projects. Understood? So when you go on doing projects, you'll get the clarity on all this subject. Okay. So that is where you get the extra edge on all this subject. It is a very simple subject. Okay. So just learn these basics. When you do it in projects, automatically you start understanding. So writing logic in Java is easiest. Remember this. So Java tells to focus only on one thing. What? Domain logic. Domain logic. Rest all backend support is there for you. Handling data support is there for you. UI support will shortly come. Only what you have to do now? Domain logic. What is domain logic? Logic related to a domain, like banking domain, insurance domain, entertainment domain, hospital domain. These are the different domains now. Clear? So I'll just show you and we'll conclude this class now. Clear? So you can do like this. I think I'll need this diagram, which on the top one. This and all we'll leave it. So collections always has to be learned with what? Database. If you want to learn proper collections, first you should know database properly. That's the accurate way to learn. Okay. Only then you can tell that I know collections. Without database, if you tell I know collections, I know Java, I know collections, nobody will agree. Understood? This is how it will be used. But unfortunately it's the same story. Other institutes will do what? Collections without database, and they'll tell, yeah, those students will tell what? I know Java, I know collections. Meaningless it is. Understood? So openly I'm telling it to you. These are all things which are very, very important. Okay. So yes, we have got the employees and all and the end of the day, what did I do here? Just see this and look at the conventions, what we follow. Till now I was saying list. Now when I create the employee list, here array list, what is the name I have given? Employee list, phone list, address list, use that suffix. This is the convention what we follow. If you give the variable name as array list A, what is A now? A for apple, finally. Understood? So follow conventions and look at the variable name, E small, L caps. Okay, tomorrow you might get some other thing, address list. Like that we actually do it. Employee name means employee names list. That's the convention. See, that's all. And it's getting stored in what? 0th index, first index, second index, because add method adds to the end. That's it. Over now. What is so big thing about it? And I'll print SOP employee list. Means it will print all the elements in the array list. That's it. So now see, if I don't override a toString method, it will print the references. That's why I'm overriding. Understood? So just I'll show you now. See, here I'm only showing you the usage of setter. Later on I'll be showing you the use of getter methods. Just learn this much. So yes, when I comment toString and print, it will print address. This is one employee. It's printing the addresses. So if you want some meaningful message, what you do? Override the toString method. So in the TO, I'll override the toString method. That's it. When you print employee list, the toString in array list is getting executed. The toString of array list will execute what? toString of your class. Like that it will call. Simple. Means I added first which one? Amogna. Then I added what? Ravi. Then I added Vinay. Means I have deleted that side. In the diagram I have deleted. Here was Amog. In the same order as you are inserting. Understood? And see, literally I have stored how many values now? 16 values. 4 here, 4 here, 4 here, 4 here. This is better way of storing, or you will go with your traditional style. Int A, int B, int C. It looks tough. At the end of the day, imagine. To learn it is tough. Okay. But once you do it like this, you can write any big application now. That is the support you are getting from the language. And for doing all this, we hardly did it in 2 days. Yesterday and today. The same thing you try to do it in any language, see, okay, gone. You can't do it. It's very difficult then. Very, very difficult. Okay. Not, yeah, and you have seen the support of only of what structure? Array structure. One small change will fill the values into what? Linked list. Imagine, do not forget that dynamic polymorphism. List L is equal to new array list, it will fill in array list. Tomorrow I don't want the employees in array list, I want in linked list. What will you do? One change, man, means you will do dynamic polymorphism. Now instead of this, what you will be doing? See, like this you do list. List is the interface, import it. So where are the employees stored now? Sorry, I have to change this variable name now. Okay, I just make it as employee list. Yeah. I'll copy paste it. Okay, fine, done. It's done. So employee list L is equal to. Okay, done. So now your employees are in which structure? Array structure. Yes, run the program. It will be storing it in array structure. Now tomorrow I decide I don't want array structure. I want linked list structure. Unimaginable, man. Just see this. No, you don't even know what is happening, but it's already put into what? A linked list. Anyway, not covered linked list, but I'm telling you the support of the language. Pre-next in double linked list, it will store now. You will get the output, not at all a problem. Linked. Import I have to do. You have to import it, because it's a class. Import it. Finished. You are getting the output. See what flexibility in Java. Change data structures in other languages. Let me see. Change. Impossible. It's a massive subject. Data structure is a massive subject, because I have told you data structure is done with what? 50-60 years of revolution. Understood? So here you can see they have brought it down to earth. In 2 days we are getting the grip of what? Data structures. It's all about coding now. You code, you'll get the grip now. That's it. Clear? Okay. So any questions you are having? Some points about ArrayList you wrote? These points we'll discuss. Okay. I think it should be clear now. I already written it. Just ArrayList is a class used to store multiple objects. It uses array data structure. It is used storing values sequentially but accesses randomly. You can grow and shrink dynamically. Duplicate values are allowed. ArrayList is not synchronized. It will store the order, means values are stored in the same order as inserted. Highlight. The elements can be accessed by, okay, these 2 points we'll be seeing it. That's tomorrow's class. Okay. Next, what are the advantages? These 2 points we'll be seeing next class tomorrow. Yeah? Okay, that's it for that.